The biggest space story this year is a visitor from beyond our solar system. Object 3I, this rare traveler comes from another star system, and some scientists even wonder if it could be an artificial object. We've talked about 3I before, but new information keeps coming in. Astronomers worldwide are actively studying this mysterious object. What's on its surface? How does it move? What is it really made of? And how can we detect more interstellar travelers like it in the future? Let's dive in. The most exciting astronomical event you can talk about right now, and for the next 6 months, is another interstellar visitor entering our solar system. Another one, because this is already the third. Since 2017, we've had 3 arrivals from deep space, from the galaxy's unknown regions. The important thing is that we spotted them, tracked them in the sky, and began studying them. The first was Oumuamua in 2017. We still don't know exactly what it was, an asteroid, a dried-out comet, or maybe even a spacecraft. The second was Comet Borisov in 2019. And now, this year, a third interstellar object was found. It's officially named 3I, short for the third interstellar object. It also has a name, Atlas. That's written in capital letters because it's an acronym. Atlas stands for the Asteroid Terrestrial-impact Last Alert System, a network of robotic telescopes that scan the skies with little human help, finding whatever interests astronomers. In this case, an asteroid, or so it seemed at first. Later, it turned out to be a comet flying toward us from deep space. Though whether it really is a comet still needs confirmation, even if it looks like one. It was officially discovered on July 1, but it had actually been seen earlier. We just didn't realize what it was. In astronomy, this happens often. We're used to it. The official discoverer is the one who first pointed out its strange properties, making everyone curious about its nature. Before that, astronomers had already photographed that part of the sky, studied it, and stored the data. Once you know where to look, it's much easier to find something. That's what happened this time too. Although July 1 marked the official announcement of the interstellar object, astronomers immediately checked their archives, nowadays digital ones, and looked at earlier positions. Where had it been before? We can calculate not only where a space object will be in the future, but also where it came from in the recent past. Could it have been captured in older images? This way, we extend the known part of its path, refine its orbit, and understand its journey better. The same happened here. Researchers working with the TESS Space Observatory, which, by the way, has 4 optical telescopes with wide fields of view, went back through its data. TESS was built to find planets around other stars, and it's been very successful. But the huge amount of data it collects every few minutes, stored in computers on Earth, allowed them to look back several months. And they found it, images from May 7. That's 2 extra months of trajectory we can now study, so we have a good chunk of its path. Let's see how this object is moving. When 3I was first spotted, it was still beyond Jupiter's orbit but moving incredibly fast, over 60 kilometers per second. That enormous speed is what revealed its interstellar origin. It's been approaching the inner solar system ever since. Calculations show that on October 3, 2025, it will pass relatively close to Mars. What does relatively close mean? 19 astronomical units, 5 times closer than Earth is to the Sun. That's still millions of kilometers away, but several spacecraft are operating near Mars, and they'll be much closer to this object than our telescopes on Earth. We'll try to observe it through their lenses. On October 3, it meets Mars. Mars's gravity will slightly alter the comet's path, bending it a bit before it continues toward the Sun. On November 3, it passes relatively near Venus, around 100 million kilometers away. Still, that's a notable approach. Then, on December 19, it makes its closest approach to Earth. But it'll be quite far, almost twice the Earth-Sun distance. Why? Because the comet will be on the far side of the Sun. Earth will be on one side, the comet on the other. The distance isn't too large to study it, but the Sun will be in the way, making observations from Earth nearly impossible. Fortunately, we have solar observatories in space, like the Solar Dynamics Observatory and the older SOHO spacecraft. They're designed to look at the Sun, using special shields to block its glare and study nearby regions. We've asked them to watch the comet as it moves behind the Sun. Next, on March 16, it will pass very close to Jupiter. Given Jupiter's huge mass, it will significantly change the comet's trajectory. Now, let's talk about some intriguing ideas. Of the 3 interstellar visitors, only one, Comet Borisov, didn't raise any questions. It looked and behaved like a normal comet. But the first one, Oumuamua, and this new object 3I, both raised doubts. They don't quite fit our understanding of natural icy bodies. Both Oumuamua and this new object move strangely. Oumuamua showed unexpected acceleration as it moved away from the Sun, not just from gravity but something else. Let's set that aside for now. This new comet arrived in an unusual way. Its orbit lies almost perfectly in the same plane as the planets in our solar system. It's as if it had a mission to pass near most of the planets. If it were a spacecraft designed to study our solar system, this is exactly how it should move. Was it planned by an intelligent civilization or just a coincidence? We don't know yet, but its path seems highly unlikely by chance. It flies directly within the planet's orbital plane, passing relatively close to Mars, Venus, and Jupiter. But it didn't come very close to Earth. Instead, it hid behind the Sun during its closest approach to us. It gives the impression of a calculated route. Study the planetary system while staying partly hidden. Of course, it could all be random, or not. These thoughts are partly inspired by the well-known American astrophysicist Avi Loeb, who has long suggested that some interstellar objects might be alien probes. Why not? Even if it's not a probe, it's still a gift from nature, a piece of another star system delivered to us. Now, with these interstellar visitors, we're getting samples from other planetary systems without having to travel there ourselves. 3 times now, we've had such visitors, but we haven't been able to study them up close. They enter and leave too fast. Spacecraft missions take years to prepare, but these objects zip through the solar system at incredible speeds. This one entered at over 60 km/s, and near the Sun, it'll reach almost 78 km/s. We've never seen anything like this inside our solar system, but it makes sense. It's moving toward us as our solar system moves toward it, combining into these high velocities. Still, we have telescopes and we're using them. So what have we learned? It does look like a comet. It's releasing gas as the Sun heats it. But here, too, there are surprises. Normally, comets start to evaporate when they cross Jupiter's orbit and approach Mars. But this one started outgassing much farther away. It's losing about 40 kilograms of water every second. That's like 4 buckets of water per second, a lot for such a cold region. Another oddity. The infrared space telescope SPHEREX recently detected the evaporation of dry ice, solid CO2, from its surface. Usually, there's not much CO2 in comets, but this one seems to have a lot, forming a dense, temporary atmosphere around its nucleus. Astronomers call this a coma. That's where the word comet comes from. In Greek, coma means hair, and indeed, comets often look like they have flowing hair. Now for the unexpected part. Space missions already in progress might help us study this object. Though we can't prepare a special probe in time, it'll leave the inner solar system in about 6 months. We do have a few spacecraft already in space that could turn their instruments toward it. First, there's Psyche. That's a NASA mission traveling to a metal-rich asteroid of the same name. It has good optical equipment on board, and its path will take it fairly close to 3 eye-second. There's the European spacecraft JUICE, headed to Jupiter's moon Europa. Its trajectory will also pass relatively near the path of this mysterious comet, allowing it to study it better than we can from Earth. So several space observatories, those watching the sun and those traveling to asteroids and moons, will join the effort to observe this comet. But is it really a comet? Let's return to the idea that it might be artificial. After all, we've long speculated that civilizations in the galaxy might exchange information or visit one another. So it's natural to consider whether some visitors could be probes. Recently, a team of young American astronomers compiled a list of key traits that could indicate an artificial origin. First, its shape. Oumuamua, for example, was long and thin, like a cigar or a pencil, about 230 meters long and 35 meters wide, a ratio of nearly 7:1. Out of millions of asteroids we've seen in our solar system, not one has that shape. The first interstellar object we met looked like that. Interesting and worth noting. Second, its motion. Again, Oumuamua behaved oddly after passing the sun, almost like it fired engines. Normally, comets outgas when heated, creating a visible tail and slightly changing course. But with Oumuamua, we saw no gas, no tail, yet it accelerated. That's suspicious. Third, its appearance, or as astronomers say, its spectral composition or color. The surface of any object tells you about its nature. Rock differs from ice. A spacecraft made of aluminum or stainless steel would reflect light differently than a natural object. So the spectrum of reflected light could give us a clue. Fourth, excess infrared radiation. Any working spacecraft generates heat. If this object is warmer than expected, that's another clue. And fifth, narrowband emission. Think of tuning a radio to one specific frequency. If this object emits radiation in a very narrow band, that could be a sign of artificial origin, like a laser or a radio transmitter. All 5 of these traits should make us take a closer look. Of course, sometimes we get it wrong. More than once, astronomers have announced a new asteroid, only to realize it's human-made. We've even rediscovered old Soviet Venus probes or Apollo rocket stages, still orbiting the sun. So far, every artificial object we've found in space was made by human hands. We're still waiting for the one made by another civilization. It's a fascinating search. If you enjoyed exploring the mysteries of the cosmos with us, make sure to subscribe, like this video, and share it with fellow space enthusiasts. Your support helps us continue our journey through the stars. Let's keep discovering together.